structural geology and introduction part. So the major contents in the structural geology is the major objectives, the introduction, and generally whatever the primary structures and secondary structures and objectives and methods of structural geology and applications of structural geology and its relation to other branches of geology. These are the major content in the first unit, being as a structural geology and introduction part. So generally, what does it mean, a structural geology? Okay, so generally, after studying this chapter, you should able to explain the primary and secondary structures. So after completion of this unit, you can able to explain, you can able to learn major things are to explain the primary and secondary structures. You can describe the methods of structural geology. You can also describe the applications of structural geology, and whereas describe the structural geology and its relationship with other branches of geology. So these are the major things which you are going to learn in this chapter, the first chapter, structural geology. Okay, so generally what does it mean, structural geology? So generally structural geology deals the study of the structural features, study of the structural features of rocks, their geographical distribution and their causes. What does it mean? Structural geology deals with the study of the structural features of rocks, structural features of rock and their geographical distribution and their causes and their causes. So this is known as structural geology. It is called as structural geology. Simply, structural geology is defined as the structural features of rock, the structural features of rocks and their geographical distribution and their geographical distribution and the causes to formation of structures and their significance causes to cause the to formation of these structures in a rock. So this is structural geology. Majorly the structural features of rocks. Okay, so generally according to the Billing, one of the geologists, according to Billing, he says that the study of architecture of the earth, understand the definition according to Billings, the study of architecture of the earth crust as it has resulted from the deformation. So according to Billings, it is defined as the study of architecture of the earth crust as it has resulted from deformation. So generally, according to MP Billings, is one of the geologists. So the architecture of the study of earth, the architecture of the earth's crust as it has resulted from deformation. So what does it mean by deformation? Formation and deformation. So formation is a process of forming of the rocks in the earth crust. That is formation, the initial period, the primary period. The process of formation, in the earth crust as a several rock units. That is formation. So deformation means, deformation is a process of destroying and disturbance the existed formations. Understand? Deformation is a process of destroying and disturbing, isn't it? Destroying and reconstruction. It is going to be reconstruct, which are already formed formation is called deformation. Okay. So generally, the structural geology aim at understanding and interpreting the form, symmetry, and geometry, and certainly the elegance and artistic assembling of the components of earth crust and all scales. So generally it means the structural geology, the major aim is to understanding and interpreting. So we need to understand and interpreting. So the form, what we are going to interpreting, the form, the symmetry, the form of rocks, symmetry of rocks, and geometry, and certainly the elegance and artistic assembling of the components of the earth crust on all scales. On all scales means from minute to broader ones or larger structures also should be interpreting. So we need to understand the major aim of the structural geology. We need to understand in a field. When you enter into the field, we need to understand the structural features. It may be form, it may be symmetry, it may be geometry, it may be other any structural variations. What you observed in a field, that should be recorded and that should be interpreting in a proper manner. And we are going to be setting a geological setup in that area. That is a major aim of structural geology. So generally, the geologists are concerned with the structural features which range in size from those observed in a outcrop to those of regional size, which are to be mostly responded on geological or structural maps. So it means the geologists are mostly concerned with structural features. So what are the structural features which range in size from those observed in an outcrop to those of regional size? So what the features which are observed in an outcrop? So to those of regional size, which are to be responded, so which has to be represented on geological or structural maps. So whatever the features, either may be small quantities or either may be broader scale or smaller scale. So the range of size from those which are observed in an outcrop, those of regional size, which are to be represented on geological or structural maps. So whatever the features which you observed in the field, from the field, that feature should be represented or interpreting in a proper manner on the geological maps, or it may be a structural maps. Okay, so the features of a still large scale, these structural features of a still, if it is a large scale, are considered in tectonics. So which is the study of features of much broader or a larger components of the earth and their causes. So tectonic is somewhat different from the structural geology. So tectonics, it can cover a broader components or larger components of the earth and their crust and their causes. So even if the features, whatever the structural features which you observed in a field, generally, even if it is still a large scale, or should be considered in tectonics. So tectonic is the study of the features of much broader components of the earth and their causes. So what are the features which are large in size or broader in size, that should be considered in the tectonics. So below that cases or below that range, we can consider such features in the structural geology part. Okay, so generally the primary and secondary structures. So once you observed, what are the structures? So the structures are produced in a rock formation or in several rock units by movement of deformation on its rock. So which is going to produce. So generally, structures are broadly two types: primary structures and secondary structures. These structures are generally, the structural features are generally two types: primary structures and secondary structures. So what are the primary structures? So generally, what are primary structures and what are secondary structures? What is the difference between these two? So generally, a structural feature is one produced in the rock by movements after the formation or after the consolidation of rock, the consolidation of the rock or rock units. So generally a structural feature, so that structural feature is one produced in the rock by movements after the formation. So the structural feature, whatever the structural feature, or simply we can call it a structure, is produced in the rock by movement after its formation. So these structures are formed generally. A structural feature is produced in the rock by movements after its formation. So here generally whatever the principles which are going to be seen, and these principles mostly we can whatever the regional scale, so structural feature is produced in the rock by movements after the rock formation or after the consolidation of rock or rock units. So generally the term structural features, or simply we can say structures, refers to the shape and attitude. The structural feature, it refers to the shape and attitude of the various rock units present in any part of the earth crust. So generally it means the term structural feature or structures, isn't it? So the term structural feature or structures, it refers to the shape and attitude. What is the attitude of the structure? The shape and attitude of the various rocks units present in any part of the earth. So it means whatever the structures which you are observed in the field, so this structure which represents the shape and moreover the attitude, the shape and attitude of the various rock units present. So the structures are various types, and as well as it has been present in the distinguished rocks. So these structures that are having a shape and attitude of the various rock units present in an part of the earth crust, any part of the earth crust, the rocks which are showing, the rocks which are having any structural features, so it refers the shape and their attitude. The structures that are originate, how these structures are originate. So the structures that are originate during the formation of rocks, during the, listen, the structures that are originate during the formation of rocks, either through depositional, either through depositional process, means mostly the depositional process in the case of sedimentary rocks, or through emplacement and recrystallization in the case of igneous rocks, are called primary structures. So what does it mean by primary structures? The structures that are originate, that are formed, that are takes place during the formation of rocks. During the formation of rock, the structures are originate during the formation of rocks, either through depositional process in the case of sedimentary rock, or emplacement or crystallization in the case of igneous rocks, are called primary structures. Understand? So if the structures are originated or formed or takes place during the formation of rocks, during the formation of rock, means while rock formation, if the structures are takes place at the same time simultaneously, understand? So the structural features, whatever the structural features are originate during the formation of rock, either it will be sedimentary rock through the depositional process, either if it is belongs to igneous rocks through the emplacement and consolidation or crystallization process. Such structures are called as primary structures. While the structures produced subsequently in the consolidated rocks by forces that tend to displace and destroy the rocks, or by metamorphism, which are called secondary structures. Understood? So the structures produced subsequently in the consolidation of rocks. So if the structures are takes place if the structures are formed or originated subsequently in the consolidated rocks. So means consolidated rocks means which are already formed. Consolidated means became hard. Consolidation means that is a crystallization or became hardened. So if the sediment rocks, that is a lithification, and if the igneous rocks, that is a crystallization process. Okay, so generally the sedimentary rocks mostly, as we know, as we came to know that in sediment rocks which are formed in the basin by weathering, erosion, transportation, and deposition in the low-lying areas. Yes. So after span of time, they are going to be diagenesis and lithification. They are became as sedimentary rocks. They are became hard. So during the depositional process, means while process of formation of sedimentary rock, if the structures are takes place, means at the same time formation of sedimentary rock, such structures are called as primary structures. Or even coming to igneous rocks, while formation of igneous rocks means magmatic crystallization by various methods. So while magmatic crystallization, at the same time, if the igneous rocks are formed, understand, if the igneous rocks, while the formation of igneous rocks, if the structures are formed itself at the same time while formation of igneous rock, then such type of structures are called primary structures. Simply, primary structures are the structures which are originated during the rock formation. Simply, primary structures are the structures which are originated during the rock formation. Simply, we can define. So, if the sedimentary rocks during the depositional period, during the depositional process, and if the igneous rocks during the crystallization process, magmatic or lava crystallization process or consolidation process. So at the same time, if the structures are formed, then we can call it as such structures are belongs to primary structures. Clear? Then secondary structures means later on the formation of rock, later the rock formation. Simply, secondary structures are the structures are produced subsequently of the rock formation. Understand? Subsequently of the rock formations. So generally by consolidation, how these sedimentary secondary structures are formed. So the structures which are produced after the consolidation of rock, mostly consolidation rocks, by forces. Understand? By forces that tend to displace, or it may be we can say uh, they are going to be displace and deform. So the secondary structures which are formed by the force, understand, which are formed by the force, and it may be by takes place, it tend to be displaced and destroy the rocks, or by metamorphism also. By metamorphism also, the displacement and destroy will takes place in the mostly as a sedimentary structures. So it means we have to understand in a broad manner, secondary structures are the structures which are formed after the rock formation or after the rock consolidation by the force. So this force generally it brings a marked changes in the existed rocks. So these forces bringing a marked changes in the existed rocks, as well as, so that when this changes, it may be displace the formation, it may be deform the formation, it may be destroy the formation, or either by metamorphism also. During the metamorphism also, the structures has been changed. So like these two ways, the secondary structures are formed in the existed rocks. Understand? So it means the major difference, what do you observe in the two types of structures? Primary structures, simply the primary structures are the structures which are originated during the rock formation. Means at the same time of process of rock formation, the structures also takes place. The structures also formed. Such type of structures are called primary structures. If the structures, if the structures are takes place after the rock formation or subsequently rock formation, then we can call it as secondary structures. Clear? So generally, the latter are resulted essential of deformational process. So the latter, mostly the resulted essential of deformational process, such as uplift, tilting, faulting, and folding. So what are the latter or subsequently bringing the marked changes in the previous rocks or pre-existing rocks as a secondary structures? So whatever the latter are resulted, the secondary structures are resulted by a essential of deformational processes. The essential of deformational processes. Already I told the deformation is a process of destroying the existed formations, displacing the existed formations. So whatever the existed formations or previous formations which are involved in the displacement, destruction, or reconstruction. So when they are subjected to these variations, these effects, then we can call it as secondary structures or lead to secondary structures. So here, generally, the latter or these secondary structures are resulted from a essential of deformational process. The essential of deformational processes. So what are the deformational process such as uplifting, the earth movements, uplifting, tilting, faulting, folding. So these are the essential deformational processes. Okay, uplifting, tilting, thrusting, faulting, and folding are the deformational processes. So because of these effects, the previous rocks are going to be change their structure, the previous or original structures. The original form is going to be changed by these processes, deformational process, because it is going to deform. The original form is going to be changed. The original form is going to be altered by the force, by the external force. It may be resulted means the tilting, faulting, folding, isn't it? Uplifting, the earth movements. So these are the sources which lead to form the secondary structures. Certain deformational structures may, however, develops in sediments before the sediments are hardened. Generally, certain deformational structures may, however, develop in sediments before the sediments are hardened into rock, that is lithification. When the sediments, what does it mean by sediments? What are the loose particles resulted by weathering process? Yes, the sediments resulted from the after followed by weathering process. So weathering process results the weathered fragments or loose sediments, the fine particles which are called sediments. These sediments are traveled by geological agents into the low-lying areas and deposit in the swampy regions or low-lying or depressional regions. Okay, so that is called deposition, the process of deposition. So followed by weathering. So certain deformational structures may, however, develop in sediments before the sediments are hardened into rock, hardened into sediment rock. Which rock? The sediments, when they are compacted, when they are hardened into, the rocks are developed, the rocks are formed, the rocks are called as, such rocks are called as sedimentary rocks. So generally the deformational structures may however develop in sediments before they harden into sedimentary rock, or in igneous rocks before they are completely solidified. So for example, some deformational structures may however develop in sediments before the sediments are hardened into rock, or if igneous rocks, if the magma or lava, if they are not completely solidified, became solid or became compact. So before solidified, so such structures which are connected with the later stages, the formative process. So generally such structures which are connected with the later stages, the formative process. So whatever the after formative process or formation process, the later stages, these structures will be takes place. So later stages of the rocks are usually distinguished. So such structures are usually distinguished from the primary structures and are termed as Peony contemporaneous structures. Very, very important objective also. Such structures are distinguished from primary structures, which is tended to be, so which are termed as pheno-contemporaneous structures. Pheno-contemporaneous structures. What are the pheno-contemporaneous structures? Some deformational structures may, however, develop in sediments before the sediments are became hardened. Before the sediments are hardened into rock, or in igneous rock before they are completely solidified. So with the later stages, the formative process, the later stage of the formative process, the structures are going to be developed, the structures are going to be takes place. Such structures are called as, so they are distinguished, means these are the distinguished from the primary structures. So primary structures are the structures which are formed during the rock formation, but these structures are developed later, the formative stages, not completely after formation or while formation, just later formative process, the developmental stages and the later stages of the formative process. So these structures are distinguishable from primary structures, which are termed as Peony contemporaneous structures. So even finally, these Peony contemporaneous structures also, most of the geologists are considered it is also a type of primary structures. It is also type of primary structures. It is not a complete process of solidification in igneous rock. Or coming to sedimentary rock, it is not completely whatever the, so what you can call it as the sedimentary rocks. If the sediments are not became completely hardened, so within the stage, but is just a slight later on the complete process of the formation. So that is why they are somewhat a slight variation from the primary structures, but finally it was also considered as one of the primary structures. Which one? Peony contemporaneous structures. Okay. Then let's see the objectives. Once we observed the whatever the objectives and methods of structural geology, once we observed the objectives, so the objectives and methods of structural geology. Once we observed the objects and methods of structural geology, I will see the major objectives and methods of structural geology. What methods you are going to follow in structural geology? So the structural geology is primarily concerned with the recognition, representation, and genetic interpretation of rock structures. So generally, the structural geology is primarily concerned with the recognition. You need to recognition the structures in the field. We need to recognize, yes, when we are in the field, we need to recognize the structures in a, we need to recognize the structures in a field. So we need to recognize and representation. So what are the representations are there? And genetic investigations. So the genetic interpretation. So we need to interpret. So how these structures are formed? What type of structures are there? So these it belongs to primary structures or secondary structures. At what type of condition these structures are formed? Such type of description or interpretation should be reported in the proper manner. So the genetic interpretation of rock structures is also required in a essential factor. It is an essential factor to recognize, to representation, and genetic interpretation of rock structures. So we need to observe the structures in the field. That is recognition. We need to notice when we are entering into the field. If there is any structures are there, we need to notice those structures and their representations and their attitudes and their genetic interpretation of rock structures. So first of all, it is necessary to study the rock bodies. So before that, first of all, it is necessary to study the rock bodies and determine their shape, size, and structural characters. Understand? So first of all, it is necessary to notice, it is necessary to study, yes, it is necessary to study the rock bodies and rock bodies and determine their shape, size, and structural characters. Understand? So structural geology is mainly concerned with the recognition, representation, and genetic investigation. So whatever the genetic interpretation and their after investigations in a field of the rock structures. So it is necessary to study the rock bodies. Understand? Before that, it is very necessary to study the rock bodies and determine their shape, size, and as well as their structural characters. Understand? So here, the structures is to be represented by means of maps. Okay, the structures is to be represented by means of maps, cross sections, and block diagrams and photographs. Okay, so how we are going to represent the structures on your map? So the structures is to be represented by means of maps, in the form of maps, by cross sections and black diagrams and photograms. In all these ways, we are going to represent the structures of a various rock units in the field. So for field work and in the preparation of geological maps, topographic maps are used as base map. So for field work is quite different from the theory which you are learn in the classroom. Yes. So field is quite different. We are practically approaching. Yes, we are practically enter into the areas of the geological terrain. Okay. So for field work and in the preparation of geological maps, it is one a part of preparation of geological map is a major part in the when you are visited the field, when you are enter into the field, we need to prepare a geological map. So if you want to prepare a geological map, we need a topographic map as a base map. So in a field work, generally, the preparation of geological maps, topographic maps are the best used, and which is mostly called as a base maps, the topographic map. So whatever we call it as. So during the field work, understand. So during the field work, as much data as possible is collected. So when you are enter into field, in your field work, you need to collect as much data as possible. Understand? So as much as data is collected and recorded from as many outcrops as possible. So it has been during your field work, you need to collect as much data as possible, and as well as and recorded from as many outcrops as possible. As many as outcrops are possible. So what does it mean by outcrop? Isn't it? So any rock exposure on the earth surface. So the exposure of the rock in any part of the earth surface is called as an outcrop. So the outcrop is a very good sign, isn't it? It's a very good symbol. It's a very good sign what is below the surface, isn't it? It can give a key. The outcrop can give. There are several. It's going to be revealed. There are several things. It is one of the biggest clue which is below the earth surface. So that is why you can also record it from as many as outcrops which is available in the field. So an outcrop is a rock's exposure on the earth surface. So which is appeared on the earth surface. You can able to see on the earth surface as a rock mass. We can call it as an outcrop. Okay. So generally, the aerial photographs and remote sensing through orbiting satellites is being widely employed for obtaining imagery photographs. So generally, the aerial photographs and remote sensing through obtaining satellite, the remote sensing through obtaining through orbiting satellites is being widely employed for obtaining imagery photographic. So even during your field work, the aerial photographs and remote sensing data will also be widely used for better convenient for the conducting of a field trip successfully or field work successfully. So these are the various other sources. of aerial photographs and remote sensing applications are also be widely used in the field work, so which is carried out by certain other works are also. Now this is what the major objectives and methods of structural geology. Then applications of structural geology. So what is the application part of structural geology? So the application of structural geology, the study of structures is fundamental to the understanding of how the crustal rocks have responded to physical processes. So by study the structures, so the study of structures is fundamental. The study of structures is fundamental to the understanding of how the crustal rocks have responded to physical processes that have been operating throughout the long geological time. So whatever the crustal rocks, how they behave, how they respond to the physical processes that have been operating throughout the long time, throughout the long geological time, masses of crustal rocks from the size of specks to the size of a continent have been shifted, rotated, uplifted, and distorted in response to earth forces. So generally, applications what once you observed the study of structures of a various rocks, the study of structures of various rocks, is to fundamental to understanding of how crustal rocks, the understanding of how crustal rocks have represented. The crustal rocks have been responded to physical process. So whatever the crustal rocks or earth crust, the rocks which are present in the earth crust, how they are going to respond to the physical process that have been operating throughout the long geological time, masses of the crustal rocks, and from the size of specks to the size of continent have been shifted, rotated, uplifted, and distorted in response to response to the earth forces. So these are the several physical forces. Understand? So these are the several physical forces which has been resulted, which have been affect the rocks which are present in the earth crust. How they are going to be respond to these effects like physical processes by earth movements, isn't it? It is going to be shifted, it is going to be rotated, it is going to uplifted, it is going to be submerging, isn't it? And distorted. Such an it is response to earth forces, the several earth forces, how the rocks are going to be respond for the variations or changes has been takes place. So generally the structures like faults, folds, mostly joints, cleavage, foliation, and lineation are abundant in the earth crust. So the structures, these are the structures like faults, folds, joints, foliation, lineation are the abundant in the earth's crust. So the knowledge of the structure, the knowledge of the structures of rock bodies is basic to the understanding of other aspects of geology. Understand? So the knowledge of the structure. So whatever the knowledge which you are gained from the field, from the rock formations, so the structures, the knowledge of the structures of rock bodies is basic to the understanding of other aspects. It's a basic to the understanding of other aspects of geology. It's a basic, it's a fundamental tool to understand better way to other aspects of geology. So the structural geology knowledge is of great importance. The structural geology knowledge is of great importance in applied fields. The structural geology is of great importance in applied fields of geology. In applied fields of geology, required a structural geology knowledge, such as groundwater hydrology, mining geology, and engineering geology. So the application part, applied fields of geology. So what are the applied fields? So groundwater hydrology, mining geology, engineering geology. So these are the application parts, applied fields of geology. So structural geology knowledge is very much essentially used in the applied field of geology, such as mining geology, engineering geology, and as well as groundwater hydrology or groundwater exploration. So in all these fields, it is essential to learn. In all these fields, the structural geology knowledge is essential to learn. It is very much important. It is widely used in these application fields of geology. Okay. So generally, in all these fields, it is mostly it is going to be widely used. So the occurrence of oil pools, for example, the occurrence of oil pools, the size and shape of ore bodies, and other important rock formations such as coal, limestone, and distribution of groundwater are very often controlled by geological structures. We see the occurrence of oil pools means oil and petroleum. Oil pools, the occurrence of oil pools, and as well as the size and shape of the ore bodies, economic minerals, the size and shape of the ore bodies, and other important rock formations. Mostly, the other important rock formation like coal, isn't it? It may be another any important rock formations. It may be like coal and other economic beneficiable bodies which has been there, even limestone and distinguished ore deposits of groundwater ore are generally the whatever the distribution of groundwater. So below the earth surface, so the groundwater has been widely distributed. It has been uneven. It is not even. It has been as uneven occurrences are there in the earth, below the earth. So whatever the occurrence of oil pools or oil and gas, and as well as the size and shape of the ore bodies, and as well as the important rock formations such as coal, isn't it? And the distribution of groundwater are very oftenly controlled by geological structures. It means, what do you understand? So economic sources, these economic sources are oftenly controlled by the geological structures. It means the economic sources which are controlled by the structural geology, means structural features. So these structural features like folds, faults, joints, foliation, lineation, which are going to be controlled these economic resources, so that it is very structural geology knowledge. It is very much useful in the other sectors. It is very much useful in the other part of the applied fields or applied part of the geology. Understand? So here, in order to learning the structural geology, we need to understand what is the investigation part. The investigation part of to finding to noticing the structural behaviors or structural features of a rock mass or several rock units present in any part of the earth crust. It is definitely showing their variations, whatever the deformational variations, that is a chances to other part of applied field. That is one of the aspect where you can see very clearly. So in all these fields, it is very much useful the structural geology knowledge. And also field of engineering geology. Coming to field of engineering geology, also the field of engineering geology also a selection of sites for dams, bridges, and other projects is based on the proper evolution of a foundation rock. Understand? So in the field of engineering geology, so most of the engineering geology, what you do, we are going to planning for construction of dams, construction of reservoirs, construction of tunnels, isn't it? So construction of roadways, isn't it? Construction any other projects which is related to civil engineering construction is based on the proper evolution of foundations of rock. So what is the foundation of rock? When you are going to, if you want to construct a dam, it is not simply just you go and see the land and open land, and go and construct. It is not the way. We need to select the site for construction of dam. Is it suitable for construction of dam site or not? What is the basement foundation is there? Is it suitable? Is it favorable? What purpose you are going to construct a dam? Does it liability? Does it have any proper applications which are going to be seen? All this knowledge should be carried. All this knowledge should be connect with the engineering geology. So whatever the results, whatever the things which are there, that is going to be connected, that is going to be linked with the engineering geology. The knowledge, the structural geology knowledge, which is widely used in the engineering geology, the field, the applied field of engineering geology is very much used. Then the structural geology and its relation to other branches of geology. The structural geology and its relation to other branches of geology. Generally, as we already studied, the structural geology knowledge, the study of structures or structural features, the study of structural features is widely used in the other branches of geology. Mostly in the applied part, already we have discussed, mostly in the applied field of geology like mining geology, hydrogeology, or groundwater, or mineral exploration, or mining geology, isn't it? And like there are several fields which are going to be widely used in order to locate a proper sites, in order to look into the after physical investigations, geophysical investigations. So generally, which has been in the field, the structural knowledge, it is also by using borehole data by geophysical process, or it may by, is there any the site, is there any mining activities are going on, or any drill holes are there. So they are giving a good summary. They are going to good earth profile which is going to be given. So in all these evolution, the structural geology, which has been the branches which are having very quite common. So which is the structural geology is going to be applied or interlinking with the other branches of geology. There are several branches which are going to be either even the stratigraphical orientation is an paleontology. So all these which are going to be utilize some of the knowledge which has been used in applied, or it has going to be interlinking or connected to the other part of the other branches of geology. So because the each and you have several branches like crystallography, mineralogy, petrology, isn't it? Economic geology, engineering geology, mining geology, isn't it? Groundwater exploration, groundwater, and civil engineering. Like there are several branches in geology. So each and every branch, it has showing their significance. It has their significance. So that much of knowledge should be useful in the other than this branch, means other branches of geology. It is going to definitely it will be useful. Okay, this is the first unit, the introduction part of structural geology. So in this chapter or in this unit, we came to know that just the what is the major objectives of the structural geology. So what are the primary structures and the secondary structures, isn't it? Then objectives and methods of structural geology. What are the major objectives and methods of structural geology, and as well as applications of structural geology. Application part, structural geological knowledge will be useful in the another branch of geology, and what are the structural geology that has been relationship with the other branches of geology. So these are the major contents which are there in the first unit. So the first unit uh, completely it's having the majorly four topics, mostly their objectives and methods of structural geology, and primary structures and secondary structures, and as well as applications of structural geology. So this is the first chapter of first unit. I hope you understand. If you have any doubt, you can raise your question. Okay, thank you. My class is over.